All right, today we're talking about the quotient rule. The quotient rule allows us to take something like the square root of a fraction and rewrite it as a fraction of square roots. This can be useful. Sometimes thinking about a fraction this way is more useful. Other times thinking about the square root of the fraction as a whole is more useful. We can flip-flop back and forth between these two definitions depending on what's more useful to us. So when we're thinking about how to simplify this, well, we can note that 49 and 100 are both perfect squares. The square root of 49 is 7. And the square root of 100 is 10. So in this problem, thinking about this as a fraction of two square roots was a more useful idea. If we jump over to something like example 2, though, 8 and 32, neither one of those are perfect squares. So if we immediately jump into thinking about this as a square root of 8 over the square root of 32, we're stuck having to simplify two radicals. I would rather think about this as a fraction, 8 32nds. 8 is a factor of 32. 8 goes into 32 4 times. So before breaking up that radical, I can use all of the wonderful fraction tools from middle school and rewrite that as the square root of 1/4. Now we're in the same situation we were just in, where we have a perfect square in the numerator and a perfect square in the denominator. So at this point, it would make sense to think about this as the square root of 1 over the square root of 4. The square root of 1 is 1, the square root of 4 is 2, so that's going to simplify to being 1/2. So the nice thing about the quotient rule is it allows us to go back and forth between these two worlds, whether we want to think about the square root of a fraction as a whole, or if we want to think about it as a square root divided by a square root. So let's jump up a little bit, this third example. This third example has a square root of 10 over a square root of 45. Neither one of those is a perfect square. So it's helpful to look at this initially, 10, 45, do they have anything in common? Unlike example 2, 10 is not a factor of 45, but we can reduce both of these by 5. 10 divided by 5 is 2. 45 divided by 5 is 9. So this is the same as 2/9. However, 9 is a perfect square. So when I rewrite this, I'm going to use that quotient rule, rewriting this as a fraction of square roots. So 2 is under a radical in the numerator. 9 is under a radical in the denominator. The square root of 2 is an ugly number, so we're just going to leave it alone. Square root of 9, on the other hand, that we can take care of. That's going to be the square root of 2 over the square root of 3. So the quotient rule, again, let us flip-flop between that big radical and these two little radicals, one of which we were able to evaluate. Last example is going to take more board space than I allocated, so let's make a new video.